So the test statistic for Anova F, this F distribution, actually depends on two parameters. So there's a different distribution for every combination of parameters. So the first combination, V1, is K minus 1, where K here is your number of treatments or number of populations. And then the second parameter, V2, is n minus k, where n here is the total number of observations. So here's a picture of an F distribution with degrees of freedom 4 and 10. That's what these quantities are, degrees of freedom. So that means that our V1 here, which is k minus 1, is equal to 4. So that means 5 groups. And then V2 is n minus k is equal to 10. And then k is equal to 5. So our n here is actually going to be 10 plus k, which is 10 plus 5, 15. So 15 total observations, and we're comparing 5 means. So notice that this is a skewed distribution, skewed to the right. So not a nice bell-shaped distribution. Well, one of the things that we're going to need to be able to find is critical values for this distribution so that we can perform our hypothesis test. So let's I designed a distribution calculator in Excel, and let's use that to find some critical values. We're going to use the inverse F tab. So first we want to find the F value with 0.05 to the right. So down in this tail here is 0.05 for part A, with k equals 3 and n equals 15. So that means that our first degrees of freedom is going to be k minus 1, which is 3 minus 1, or 2. And then our second degree of freedom is going to be n minus k, which is 15 minus 3, or 12. So let's go to the distribution calculator. So you'll open it up, it'll look like this. You'll see all these tabs across the bottom. You want to go to the inverse F distribution tab. So our numerator degrees of freedom, k minus 1, is 2. So we'll type a 2 in there. Our denominator degrees of freedom, n minus k, was 12. 12 there. And then our alpha here was 0.05. And so our critical value there, 3.88. So this value is 3.88. So we would write that as F 0.05 equals 3.88 with those degrees of freedom. Let's try another one, F 0.01. So now this area will be 0.01 instead of 0.05. We want to find the F value here that goes with 0.01, with k is 6 and n is 20. So our degrees of freedom here, V1 is going to be k minus 1, so 5. And then V2 is going to be n minus k, 20 minus 6, 14. So then our F value, F 0.01, with those degrees of freedom, go to the distribution calculator. So alpha now is 0.01. Degrees of freedom are 5 and 14. So 5 is call that numerator degrees of freedom, and 14 denominator. So 4.69 to 2 decimal places.